All right, we got a calculator company, which they should be extinct. Whatever. We have this is their cost function. This function is essentially how much it costs them to produce another calculator, and we would like the rate of change. So, what is the price increasing by at 100 calculators? Okay. So after they make their 100th calculator, to make the next calculator, essentially, what should the slope be? What should it be costing them as a cost function? So, because we're looking for an instantaneous rate of change again, we're using that same function we had before, the change in y over the change in x, which is equal to our f at a plus h minus f at a, all over a value of h. So we're going to be finding the limit of h as it approaches 0, an instantaneous rate of change. In order to find f at a, we have to plug 100 into this. Okay. 1,100, is that what it is?
Yeah.
Beautiful. So our cost function, we'll plug the values in and then go with you on your word. 10 root 10 plus 1,000. Yeah, that's exactly what it is. 1,100. Perfect. So we have our f at a. The other part of our function, our cost at 100 plus h, is a little different. We have 100 root, this was the x before, right? Yeah. So 100 plus h plus 1,000 here. Okay? We divide by 10. We could divide by 10 if you like to go through this all. But essentially our idea here is we're going to be taking this value here and we're going to be plugging it into our equation. There's not much else for us to do for this, so this is going to be this part of the function. We're going to plug it directly into our function now. So our change in y over our change in x, which is the limit as h is approaching 0, we'll plug it all in, becomes 10, 100 plus h plus 1,000. Subtract 1,100, which was our f at a, and this is our f at a plus h. Okay. I'll highlight those two so we can see exactly what we did. Okay. And this was our f at a, all over the value of h. So we can simplify what's on top, and then we'll have to do some rationalizing. We get the limit of h as it approaches 0 to be 10 root 100 plus h minus 100. Okay, all over h. Now this one being a little different than before, we're going to rationalize it. We're going to be multiplying this by 10 root 100 plus h plus 100. Remember, we use the opposite over operation. We're going to do that on both the top and the bottom. Plus h plus 100. When we go to rationalize it, our limit as h approaches 0 then becomes 100 times 100 plus h minus 100 times 100, 10,000? 1,000, 10,000. 10,000 all over h times 100 is h plus 100. Okay. Now these two values, if we look, this will become 100 times 100, which is what? 10,000. So we're going to have positive 10,000 minus 10,000. What's going to happen? They'll cancel out. What will we only have left on top? Not 100. Oh, yeah, sorry. Yeah, 100h. Thank you. So we only have 100h on top. So with our 100h on top, we can then simplify by eliminating the h on both the top and the bottom of this function. Got to rewrite a lot of the same stuff. Okay. So now what we can do is eliminate this h here. This h has then been eliminated. We have 100 over 10 root 100 plus h plus 100. I'll put the line in after. At this point, we're hoping we're able to substitute h for 0. And let's mentally think this process out. If I plug in 0, we're looking for root of 100. Root of 100 is 10. 10 times 10 is 100, plus 100 is 200. So we have 100 over 200, which is what value? That's right. So the limit of h as it approaches 0 is a half. And if we put it in dollar values, what is their cost changing at this point? Costing them 50 cents to make another calculator. The cost increases by 50 cents.